Okay, so before we proceed to lab report, pre-lab number 3, okay, what I want you guys to see is this one. Okay, let's go through the lab report number 2. So lab report number 2, basically no major issues. Okay, most of you got it correct. So what I want to go through with you guys is just some of the mistake that got more than one student did in your experiment 2. Okay, so in terms of titles, objective, most of you got it correct now. So you copy this. Okay, apparatus. One thing that you guys forgot to write down is the sensitivity for the phyphox apps. Okay, it should be plus minus 0.001 second. So first few lab report that I marked, I forgot to put a bracket here. Okay, I overlooked this part. So you guys just go through it and just add a notes here. Even phyphox apps, okay, even though it is a digital tools, it is an apps, it also comes with uncertainty. All right. So the uncertainty for a digital tools is the smallest scale. So smallest scale in a phyphox app is plus minus 0.001 second. Okay, now let's look at the diagram. Okay, let's look at the diagram. Now, first few report, okay, that I marked, I wrote a few comment there, and I think I wrote it down in a way I wouldn't say it's correct. Okay, I use a wrong phrase. It's not that you have to put the ruler at the tips of the pen, but you need to put the ruler close to the tips of the pen. Okay, not at. It should be close to the tips of the pen. Why? Because if you put it too far away, then it's very hard for you to measure the distance. Okay, to maintain the right distance, to maintain the right position. So you try to put the ruler close to the tips of the pen, and then you put the pen, okay, the hanging clip at the edge of the wall. All right, some of you put it at the middle of the wall. Then when you drop the object, isn't it will touch the object? It will slide down with a frictional force if you put it beside the object, beside the wall. Okay, ada yang lekat, ada yang letak pen di tengah-tengah dinding. Okay, this is your wall, and then this is how you put the pen. So your hanging object is actually touching the wall when it falls. So in that case, definitely you're going to get a wrong answer. Okay, because you're adding frictional force. So what you should do, actually this is a wall, and then this is your pen. The tip of the pen is just right at the edge, just right before the edge of the wall. Okay, that's what you should do. And then the ruler is at the edge of the wall. Don't put it too far away. If you put it too far away, sometimes it's very hard for you to maintain its level. All right, to measure the level. So you use another ruler to make sure the level, okay, to measure the height. Okay, and one mistake that I noticed from some of the picture, okay, the height that you are measuring, it should be the height from the clip, from the metal clip, not from the pen. Okay, ada yang ukur dari pen. Okay, you measure from pen. So in this case, this is wrong. All right, if you measure from pen, then you got the wrong height already. You should measure the height from the clip. So this is the correct height. All right, so from the picture itself, I noticed a few mistakes that you guys make. Okay, you guys did. So try to put the ruler close to the edge, okay, and then you put the clip beside it. Got one example which is very good, okay, but then I didn't take the picture out because the picture got too many room informations. Okay, dia tangkap gambar tapi dia tangkap sekali dengan keadaan bilik dia. Okay, so that one I think is improper to show a whole class, so I didn't put it here. So how she did the experiment, I think is a very good idea. Okay, she put the tape on the edge, on the other side of the wall. Okay, so basically the pen is here, and then the tape is here. Okay, the tape is at the edge. So it formed a 90 degree. In this case, actually it's easier for you to measure the height of the clip. Okay, dia letak sebelah dinding sini, dia letak pen, sebelah dinding lagi, yang perpendicular, yang corner satu lagi, dia letak dia punya ruler. So dia actually ruler dengan pen dia form 90 degree. Okay, dia form 90 degree. So in that case, actually it's easier for you to measure the height of the clip. And I think that is a very brilliant idea, okay, compared to the original setup. Okay, so so far this one no major issue. Okay, now for this experiment, the procedure I go through very quick. So I just take a few, one or two procedure to go through. If you got it correct, then I assume all correct, right? So this one, okay, the table, okay, only got one mistake because the uncertainty should be plus minus 0.01. Okay, you give me 0.001. So you give me 0.01, 10 is missing. Okay, but then you see the times that you record, all of them, they come in 3 decimal places. So obviously, is your uncertainty is incorrect. Okay, uncertainty yang salah, bukan nilai yang salah, because all this value you give me in the 3 decimal places. So you got a 1 mistake here. So in an exam, this one, okay, 1 mark will be deducted. Okay. So even though it's just a careless mistake, but because you make a mistake here, 1 mark will be deducted. Okay, so actually this is wrong. It should be 70.0. Okay, 70.0 cm, because all your values, they are given in the 3 significant figures. So we better keep it 3 significant figures. All right, so unit missing. Okay, unit is missing. 1 mark will be deducted. So you got a title. Okay, now this one, you got a major issues in your skill. Okay, I mentioned in the previous class, okay, the interval must be the same. Okay, the interval must be equal. But what you are doing here, you give me 0.02 and then you jump to 0.04. So the first interval is 0.04 and then you go back to 0.02 and then this one you give me, the interval is 0.01. So the scale is wrong. Scale is wrong, 1 mark will be deducted. Okay, 1 mark will be deducted. And then the rest, okay, the rest will check the plot. Okay, for this experiment, I didn't check the plot. I just calculate the number of plot. So if the number of plot is correct, then I assume you got it right. Okay, but this one, okay, even the best fit line is wrong. Why? Because you see all your plot, they are above the line. Okay, so you got the marks for centroid, but this is not best fit. Okay, this is not best fit line. Why? Because you see 1 point, 2 point, 3, 4. All 4 of them, they located above the line. Okay, isn't I told you that best fit line, it comes with 2 conditions. The first condition is must truth centroid. Okay, it must truth centroid. And then the second condition, the point must be balanced. Okay, what does it mean by balance? If you got 2 points above, then the other 2 points should be below the line. So you need to adjust until you get a balanced line. All right, so since it is not best fit line, 1 mark will be deducted again. Okay, 1 mark will be deducted again. So 3 marks gone from the graph itself. And then calculations, so far, okay, you got the correct decimal places. This one, 1 decimal places. This one, 3 decimal places. So you got a 411 cm as -2. And then you calculate it, you got change it into meter per second square. Okay, so got a 1 or 2 report, you leave the answer in cm as -2. That is wrong. Okay, because I told you already, what I want is m as -2. This is the unit. Okay, this is the unit that I want. So from here now, because you see, you got such a huge error because of what? Because of your graph. Okay, you got wrong scale in your graph, therefore your gradient is wrong. So in your calculations, you got a more than 10% error. So in this experiment, actually is quite hard to get an error that is more than 5%. All right, it's quite hard to get an error that's more than 5%. You got more than 5% because of the error that you make in your graph. Okay, so you got a 16.21 errors, even though it is still within acceptable range. So I told you guys already, acceptable range is 20%. So this is the things that you should mention in your first paragraph. But most of you didn't mention it, but I think it's okay lah, because at least you got write down the value for G, you got write down the value for the percentage of error. Okay, so one additional step is you can discuss it. Okay, so the result is acceptable. So the theoretical value, okay, you mentioned the theoretical value, which is good. And then you mentioned the values that you obtain. You mentioned the percentage of error. You say it is acceptable, okay, but you didn't mention why. So acceptable, why? Because the error is less than 20%. Okay, because the error is less than 20%. So there are some error causes. Okay, usually this is what students will write before they start the next paragraph. So next paragraph, okay, explain and give example. Let's see what is the mistake. So the errors that can cause inaccurate, okay, result during this experiment is random error. This error happens because the surrounding during the experiment is too noisy. Now, what does it mean by too noisy? What is making the noise? What is causing the noise? So you try to give an example. Okay, so I think got one of the examples, say because of the banging of the door. Well, that is the things that can be avoided. Usually in error, we try to give something that cannot be avoided when you conduct the experiment. Okay, so if you say banging the door give you the noise, then you just repeat that step again. You just repeat the taking the data for that height again. Okay, because maybe when you record your family members, they bang the door, so you got an incorrect value for that particular height. Then in that case, at that moment, you can actually repeat the experiment. So it shouldn't be an error. Okay, it shouldn't be an error. So now you say noise, you try to give something that cannot be avoided. So you think about it. What is a noise that cannot be avoided in your house? Okay, so don't just give me a too noisy. Okay, then done. What is the things that causes a noise? Okay, what makes a noise? What create a noise in your house? So you try to explain a bit. So other than that, environmental errors also happens. Okay, okay, this is due to the conditions of the experiment is too windy. So what happens when it is too windy? That one you need to explain a bit as well. Okay, you cannot tell me it's too windy. For me, okay, maybe I think windy is not an issue. Why windy is an issue? You need to explain a little bit. Okay, that's why I say explain. All right, I say explain and give examples. All right, so to avoid a random error, do the experiment in a quiet place. Actually, you need to define what is quiet place. Okay, for me, the place that you think is noisy, maybe for me is quiet. All right, so try to think how to relate it to the quiet place. What is the condition? What is the things that makes you define that place as a quiet place? Okay, so a lot of you give me this error and these precautions. So some of it I will just stick lah, because I think I want to explain in the class. That's why I didn't go and correct every lab report. All right, so just take note. If you say noisy, then you give some example. Okay, and the example should be something that cannot be avoided. So to overcome that error, okay, you try to think, what should you do? Okay, what should you do? So to avoid the environmental error, close the fan during the experiment to reduce the air resistance. Okay, now you say too windy, the environment is too windy, and then now you say close the fans, so fans cause the wind, I don't know. Okay, so actually, windy, you need to explain a little bit. Okay, you just say windy is not enough. This wind is coming from where? You didn't tell me. Okay, how does it affect the reading results? Right? So, okay. And then fans, you say air resistance. Actually, I would say air resistance is not coming from fan though. Okay, never mind. This one I'll keep it for our next few lab report, because quite a lot of you give a wrong error when it comes to fan. Okay, last, okay, by doing this experiment, the acceleration is due to gravity. You got it here, okay, which is correct. And then you need to mention whether the objective is achieved or not. Okay, so you need to add one more sentence. Objective is achieved. Okay, or the value can be determined. Okay, the acceleration due to gravity can be determined from the experiment. All right, so that is a mistake in this first report. So far, I think no major issue. Okay, just some minor error that you need to be careful. So now let's go through the second lab report. So second lab report, okay, again, the same mistake. So this one, 0.001 second. Okay, so procedure again, you use your, isn't it? I say IU, we, they shouldn't comes out in your lab report, right? So, and also I think this report, you didn't change it to the passive sentence, all right? You didn't change it to the passive sentence. So, pergi tengok report lain, macam mana orang tukar menjadi passive sentence. Okay, so tables correct. Okay, no unique, no unique. Okay, so where is the unique? Okay, and then, okay, so this is incorrect decimal point. So in your exam, okay, even though you got the values correct, 4.76, for example, is correct, but then because of an incorrect decimal point, okay, decimal places, 1 mark will be deducted. Okay, 1 mark will be deducted because it shows that you don't have the skill to get the reading, to take the reading out from your report. All right, so how to get a correct reading from your graph? Okay, make sure you go and rewatch the experiment from and watch the video from the previous practical class, because I showed you step by step how to get it. Okay, and in this class T2, I think only 2 students got the incorrect decimal places. All right, the rest 20 of you got it correct, which is very good, which means you pay attention in my class. All right, so this one you got it incorrect. Make sure you rewatch the video, see how to determine it. All right, because you see, not just the incorrect decimal places, but inconsistent. This one you give me 3 decimal places. This one you give me 2 decimal places. So in this case, it's still considered as, it's also considered as wrong. All right, so 1 mark will be deducted. So the rest of the calculation is correct. Tak ada masalah. So let's see. Okay, now again, you use your in your discussion. So a lab report, you shouldn't have all this term. Okay, you shouldn't have all this term. So the air resistance will occur when the fan is switched on. Now, air resistance is not coming from fans. Okay, when you switch on the fan, actually I would say air turbulence is a better words to use. Okay, perkataan yang lebih sesuai. So it's not air resistance. All right. So in a doing free fall experiment, your stopwatch may run constantly faster. Okay, so if it runs constantly faster, how do you know? That is my questions. How do you know that it runs constantly faster? You need to explain. What makes you think it runs constantly faster? All right. And then the fans switch off. Okay lah, this one I accept low. And then in a precaution, stopwatch need to start simultaneously. Well, this is what you should do, right? Then how can it be a precaution? So first precaution is correct, second precaution is wrong, okay? This is already something that you must do. So you shouldn't put it in your precaution, okay? You shouldn't put it in your precautions. Okay, so where is the other? Okay, so in this case, I will assume you have just one precautions lah. Okay, I won't take it as 2 precautions, 2 error. So this one, the things that you need to take note is your, all right, this one, this IU, we, they, all those pronouns, it shouldn't comes out in your lab report. Okay, now lab report number 3. Okay, lab report number 3. Let's see. So theory and everything is correct. This one is okay. Okay lah, this one I think is all right. So procedure, everything is fine. Now you see how people is doing. Is plotted, is tabulated, is determined, okay, and then is compared with the standard value. So this is what you should do in your procedure. All right, you need to rephrase the sentence given. So table, most of you got it correct. All right, so this one, the centroid is correct because it comes with a unit. And then, all right, so this one, you got it wrong. Why? Because centroid, the symbol for centroid is wrong. So if the symbol for centroid is wrong, then it will be treated as one of the data point. All right, it means you don't have a centroid, 1 mark will be deducted, and then you put an additional data point, another 1 mark will be deducted. All right, because by right, you should have a 6 plot only. Okay, 6 plot, but now you have 7. So in this case, it's considered as wrong. So be extra careful with the symbol. Okay, centroid, it should come with a circle. Right, without circle, it's considered as wrong. Okay, so this picture is very nice. So yang snap gambar yang blur punya, okay, you guys can learn from him. Okay, so tengok gambar cantik, and I can see clearly. I can see every small boxes here. So this is a very nice picture. Okay, some of the picture is very blur until I couldn't see the readings. I couldn't see the box. Okay, so in that case, in your practical test, all right, actually that is not good. Okay, if you give me a very blur diagram, I read it wrong, then mark will be deducted. Okay, you should give me a nice clear picture like this one. All right, and some of you snap the picture without axis. If without axis, how am I going to know whether it's correct or not, right? So make sure you snap it clear. Okay, you make sure your picture is clear. Now, actually, these 2 sentences you don't have to show it. Okay, don't need to show. Okay, okay, don't need to show. So this one is just for you to know how many decimal places to be used in your substitution. Okay, so you got the calculations correct. Okay, you got the substitutions correct, but then your final answer, where is the unique? So you got everything's correct, but without unique, 1 mark will be deducted. Okay, 1 mark will be deducted without unique. So even if it's just M, not G yet, but you still need to include its unique. All right, so M must come with unique, G must come with correct unique. So this is correct. So you calculate the theoretical, you calculate the percentage of error, also correct. Okay, so basically no major issue. The issue is in the graph. Okay, the things that I want to show you is don't forget to put a circle in your centroid, because without circle, 2 marks gone. All right, you have 7 plot here, and then you don't have centroid. So 1 mark for centroid is gone, 1 mark for plotting is gone. Okay, so this report I think got a good discussion if I'm not mistaken. Let's see. So the accelerations due to gravity in this experiment, okay, good. And then it's slightly slower than the theoretical value. So the percentage of experiment is 1.12. Then you should add one more sentence. Okay, it is accepted because the error is less than 20%. Okay, so you add more sentence because it's less than 20%. So the source of error, okay, now this is the reasons why I think you guys got the wrong terms in your explanation. What is the meanings of resistance? Resistance means it's opposed, it's against the motion. If it is opposing the motion, it's against the motion, how can it makes the object to move faster, right? It should slow down the object. If it is air resistant, it resists the motion. But then in most of the discussion, what you guys wrote is that because of the fan, okay, the fan generate air resistance and the air resistance causes object to move faster. Isn't it weird? Air resistance, it should resist the motion. But your explanation is air resistance causes the object to move faster. Okay, this one I got it wrong. This one you got the correct answer because you say it increase the time. Okay, some say increase the speed of the object. So increase the times is correct. Okay, this one I overlook it. So ini betul, tak ada masalah. So this one is correct. So but not air resistant. Okay, that's why I say a better term should be air turbulence. Okay, or air flow. Okay, extra airflow or something. Air resistance pelik. Okay, air resistance pelik. So you say air resistant increase the time. Oh, okay, this one is not fan. Okay, this one is not fan yet because I read too many fan. I assume it is fan as well. Okay, but when it comes to fan, okay, fan won't cause air resistance. Okay, fan won't cause air resistance. Fans cause air turbulence or air flow, and it causes the object to drop faster. Okay, if object drop faster, then the times will be shorter. All right, so you guys have to explain it. So a lot of you give me fans causes air resistance causes the object to drop faster. So pelik lah, okay, I would say. Because the air resistance by right, it should resist the change. So this lab report, I think it is okay because I overlook it. I thought it mentions about fan. Okay, so it's correct. Okay, it's correct. So as the time increase, now you see, this is how you should explain. So you say air resistance causes the object to drop slower, therefore the time increase. So as the time increase, the values of G calculated will be smaller. All right, so explain. How is it going to affect your result? So this is a very good explanation. Okay, good explanation. So got mentions, how is it affect your reading? So another error in the experiment is the height, which is not consistent in 3 reading. Okay, this may be due to the ball pen, which is moved slightly down after the metal clip was hung on it, or when you press the clip. Okay, when you press the clip when it's being released. So the slight change in the height will affect the times taken for the metal clips to fall. So this is another very good error in your experiment. Okay, and I'm surprised not many of you mentioned this error. Now you tap the pen. Okay, you tap the pen. When you hang the metal clip, actually it will slightly move. Okay, and because you just tap the pen with a tap here, this pen is not being hung in a very firm way. Okay, it's not firm. So actually this pen, it can keep moving. Okay, when you hang the object, when you click the ball pen, this is actually a very good error in this experiment. Okay, but I'm surprised not many of you mention it. Okay, so this thing, it can affect. Okay, this should be a constant variable, but then because of you're doing it in your house, you don't have a proper apparatus, so it is a very good error. So the precaution to minimize the effects of air resistance is carried out in a closed room, and the fan must be turned off. Oh, okay, that's why I think you mentioned about the fan, because of your precaution. Okay, so fan won't cause resistance, all right, because the resistance is a resist the motions, and fans will only cause it to drop faster because your fan is coming from up there, right? You hang the fan up above the experiment. So when you have when you switch on the fan, actually your object will move faster, will drop faster. Okay, so to reduce airflow or air turbulence, then the fan must be turned off throughout the experiment. So meanwhile, to have a more consistent and accurate height, each time when the metal clips are hung to the pan, place a ruler near at the bottom of the paper clip to adjust the positions of the pan, okay, until the height is as stated in the procedure. Okay, so he check it twice. All right, so after the hangs a clip, double check it again with another ruler, okay, horizontal ruler. So this can be one of the precaution. All right, actually an additional ruler can be used as a very good precaution in your experiment. So this is the types of the discussions that I want. Okay, bukan discussion satu ayat. The error is random error, habis cerita, and the precautions we take average value. Then, okay, so that is not a good error and good precautions. All right, so what you should do is like this one. You explain. So this report got a very good explanations here. Okay, so the conclusions, the assurances, the due to gravity determined in this experiment is 9.7. Okay, so actually you don't have to mention theoretical, but if you want to mention, okay, nothing's wrong. Okay, go ahead, tak ada masalah. The objective of the experiments to determine the assertion is achieved. Okay, so good. So just 2 sentences. Conclusions don't have to be long. Okay, 2 sentences, they are more than enough to conclude the whole experiment, to sum up the whole experiment. You say it is achieved. What is the proof? The proof is you got this reading. Done. Okay, then that is a good conclusions already. Okay, so experiment 4. So experiment 4, let's see what is the mistake. Okay, so again, you forgot to give me the sensitivity for the phyphox apps. Okay, so conclusions, was. So go through it again, okay? So is betul, was salah. Okay, so you got the correct table, you label it correctly, you got everything's correct in the table. Okay, now this one. Okay, in your graph, your smallest scale is 1. Okay, not 0.5, but when you calculate it, you put 0.5, then it becomes 0.25, so you got it wrong. All right, so you got the wrong scale, therefore your substitution is wrong. So substitution is wrong, 1 mark will be deducted. All right, so this is because of a careless mistake. Mungkin dalam otak kamu sudah kira siap-siap, but when you write it down, you calculate it again. So it becomes 2 decimal places. Okay, so but you still got a correct reading. So in your exam, you don't have to worry. Even you got the substitutions wrong, but you got the correct reading, you still get this 1 mark. Okay, you still get this 1 mark. So only 1 mark will be deducted. Okay, because you got the correct equation. Equations 1 mark, and then answer 1 mark. Some of you didn't give me this equation. If you didn't give me these equations, you got correct answer, then that is fine. But if you didn't give me these equations and you got the wrong answer, then 3 marks will be deducted. Okay, including the marks for the equation, because this equation is worth 1 mark. All right. So just write it down. Okay, it won't take up a lot of time, maybe just 2 seconds for you to write down y2 minus y1 divided by x2 minus x1. Okay, 1 saat atau 2 saat saja untuk kamu tulis equations ini. Jadi tulis sahaja. Okay, tulis sahaja to save, to secure this 1 mark. Okay, to secure this 1 mark. So by comparisons, you got m equals to half g, so you got the correct calculations. Okay, so you got 8.32, and then you calculate it, you got a 15.19%. Okay, now this is the things that I want to show you. Okay, you don't have to mention the value for every height that you measure. In your discussions, you just mention the result. You just discuss the result. So what is the result? This is your result. Okay, this is your result. And this is the only things that you need to discuss in your discussion. You don't discuss every value in this table. Okay, this is just a we call raw data. Raw data, you don't need to mention it in your discussion. Okay, so you see, you mentioned the raw data in your discussion. Okay, actually, it's not needed. Okay, you say 45 height, you got this value. 65 height, then you got this value, and so on. Blah blah blah. It's not needed. All this we call it raw data, and it should be in your table in observation. Okay, table in observation. So you don't need to mention it in your discussions again. So what you need is the assertions due to gravity is 8.32 meter per second. And then what is the error? Percentage of error. Okay, percentage of error. So that is the things that you didn't mention in your first paragraph. Okay, so you put it in the second paragraph. Okay. And then thus assertions due to gravity is accepted. Why? You say it's accepted. Why? What makes you do such a judgment? Okay, you say it's accepted. Reason. Okay, see, you don't have error and precautions in your lab report. So no error, no precautions, straight away 4 marks gone. I don't even have to mark. 4 marka gone. So in your official practical test, total mark is 15. Okay, total mark is 15. So usually in your report writing test, I think we give a total of 30 marks. So divide by 2. So 4 marks gone means that at maximum you can only get 13s over 15. Okay, 13s over 15. Okay, so conclusions, again, you see you mentioned the reading for every single height, every single raw data. Actually, this is not needed. Okay, tak payah. So this is the wrong way of doing conclusions and also doing a discussion. So if you don't know how to do a conclusion and discussions, you try to go back, so go through the video again, video for today class and video for previous sections class, okay, previous class. Because I've showed you a few good example there, how to do a good discussion and how to do a good conclusions. Okay, so a table, you got a h against t square, and then you got a correct table. So this table is fine, no major issue. All right. Okay, so one more thing that I forgot to mention. Okay, I forgot to take in a sample report. This triangle should be dotted line. Okay, it should be dotted line. So the only yeah. So the only solid line that should exist in your report is the graph. Okay, this is the only solid line that you should have. So this triangle, it should be dotted line. Okay, it should be dotted line. Don't give me solid line. All right, don't give a solid line, you give dotted line. So dotted line for the triangles, and remember the side must be greater than xcm and xcm. So far, most of you got it correct. Only I think 1 or 2 of you give me less than xcm. Okay, it should be greater than xcm. Oh yeah, I forgot to mention one thing. Okay, there is a change in the marking scheme this year. Okay, so in the previous sections, I told you the graph must be larger than 50% of the graph paper. This year, they changed it to 60% of the graph paper. Okay, the size of the graph. So how do we determine the size? We look at the first plot, we look at the last plot. Okay, so the height must be larger than 60% of the graph paper. The width must also be larger than 60%. So apparently this graph is smaller than 50%. Okay, because you have only here until this line. So actually this is a very, very small graph. Okay, so this graph is too small. So you need to make sure your graph is larger than 60% of graph paper. This is a new rule this year. Okay, previously they just want 50%. This year they increased to 60%. They want a slightly bigger graph. Right, so a picture is missing. Okay, now lab report number 5. Lab report number 5, the things that I want to show you is the discussion. Okay, so it's not the tips. Okay, it should be close to the tips. Tapi ini macam tak nampak ruler. Okay, and this one, I think you put it too close to the door. Okay, so when you drop it, there will be a frictions between the clip and the door. Okay, no major issues in the calculations. Okay, now missing plot. Okay, you should have 6 plot. Now you have only 1, 2, 3, 4, 5. 1 plot missing. 1 plot missing, minus 1 mark. Okay, 1 plot missing, minus 1 mark. Okay, so no major issue. Okay, the issue is also the scale. The scale is fine. Okay, the scale is fine. 2, 4, 6. Okay. Oh yeah, it's wrong. Why is it wrong? Because you miss out one value. Okay, satu nilai hilang. What is the values that is missing? 0.02, 0.04. Where is your 0.06? Okay, so 0.08, 0.10, 0.12, 14, 16. So you miss out one value. Okay, you miss out one value. 0.06 missing. So another marks will be deducted. Unique, 1 mark again gone. Okay, so let's see. Okay, now this is the things that you must do in your lab report. You shouldn't put it as your error and precaution. Okay, the things that you must do, the thing that is being mentioned, it shouldn't comes out in your error and precaution. Now you say the error of the experiment is the size of the graph paper is less than the 50% of the graph. Okay, the graph is less than 50%. No, this is the marking scheme. This is what I told you. This is what you should do. This is not an error in experiment. Did you do experiment of graph? No, right? You did experiments. You did a free fall experiment. You are not doing experiment of graph. So why do you mention graph in your discussion? Okay, the size of the graph is less than 50%. Okay, no, the precaution step. No, this is not precaution step. It has nothing to do with the experiment. Remember, your experiment is a free fall experiment. It's this one. So you need to mention the error that can be found in this setup. Okay, not in your graph paper. Okay, so the precautions, the error and precaution for this experiment is totally wrong. Okay, and not just one of you, I think got 2 or 3 of you, you give me this error and these precautions. So maybe you discuss among yourself, I don't know, but this is not the right way of doing it. Okay, this is not the right way of doing it. So the precautions that can be taken, no, this is not. This is the marking scheme. Okay, and then take the size of the right angle 50%. Also, no, this is also the marking scheme that I told you what you should do in your calculation, not in your experiment. Right, so experiment, you must refer to the procedure, you must refer to your own setup. So this one, 4 mark is gone. All right, so based on marks that I calculated just now, 1 mark, 2 marks, 3 marks, 3 marks, got this 4. So assume full mark is 30 marks. So now you got a 7 marks deducted, so 23 over 30. So it becomes now 11.5 over 15. So this is actually a very low mark in your experiment, okay, in your report writing test. A good report, you should score at least 14 over 15. This is what I call good report. Okay, this is a minimum marks. If you want to score an A in your physics, you must at least get 14 over 15 marks. Okay, so assuming this lab report full mark is 30, now 7 marks is being deducted because of all this error, all this minor error. So after I divide by 2, you got a 11.5 over 15 marks. So 11.5 over 15 marks, actually this one is considered quite bad already. All right, so a good report should be above 14. All right, the minimums you can get, it should be 13. You shouldn't get below 13 because we have already gone through all of the steps. All right, we have to try like 7 lab report before your practical test. So you shouldn't get less than 13. Even 13 is considered as wrong, as low marks already. A good score should be above 14. Okay, and in a previous year, your senior, a lot of them, they score 15 over 15. So if you can follow the instructions that I gave you, follow the thing that I showed you in the class, then it shouldn't be an issue for you to get above 14 marks. Alright, kalau kita tengok balik report hari ini, most of them, they got above 14. Alright, just some minor issue. Okay, so this one, no discussions. Of course, tak ada marker. Okay, so this one, okay, this one I think considered as a full marks. No, not full marks because of this. Okay, and also because of this one. Okay, so it's 27 over 30. So this one is 13.5 over 15. 13.5 consider okay only. Okay, the okay marks. So a good lab report should be above 14. Okay, should be above 14. And actually, it's not hard to score 14 over 15. Okay, so a T2, if you go through your lab report, I think there are 4 or 5 of you got full marks in your lab report this time. Alright, so bukan susah nak dapat full marks. So you just have to avoid all this error. This one, okay, this one now, this experiment 2, you already know what is the mistake. You got these 2 marks being deducted because of a circle. So you won't repeat it again, right, next time. So you should score more than 14 next time. Okay, because your discussion is considered very good already, so no issue in your discussion. So yang lain cuma kena berhati-hati di part discussion. Okay. So we are done with experiment 2A. So far any questions? Ada apa-apa nak tanya? So I give you 5 minutes break. Okay, you can write down the things that I mentioned just now, the things that you think you have made a mistake, and so on. So at D3, you just write down the important things first. I will mark your lab report later today. Okay, I will definitely mark it, don't worry. Okay, so at T2 sudah dapat balik semua. So now you guys can jot down where is the mistake. So let's take a 5-minute break. Then we are going to go through the experiment 3, simple harmonic motions.
Madam?
Yes.
I want to ask about the experiment 2B. What is
Okay.
it about? I don't really understand about horizontal motion. What are we supposed to do? I mean, you mentioned about graph. So what exactly?
No, now if you look at the projectile motions, if you recall what is a projectile motions, it should be projectile motion is a 2D motion. That's why you have a horizontal and a vertical motions. Wait, yeah. Where is my projectile diagram?
So you should have your range, is it, in the experiment?
Yes, that is the things that you want to measure, right? Because you drop something at the edge. So consider this is the edge of the table. And then you drop a ball. So you got the track, you let it drops. Okay, you let the ball drops from the track. And then when it drops, what are you going to do? You measure the range. So this range is considered as X component of your projectile motion. So the Y component is this height, the height of the table. This is your Y component.
But when we did our experiment, we didn't measure the range, right, as per as our procedure.
Let's see. Practical class, your lab manual. This is okay. So by referring to figure 2.2, okay, now this is okay, the range R is given. So this is how you conduct the experiment. So this is a steel ball, the initial position. And then when it reached the edge, this is the starting point actually. Okay, this is a starting point of projectile motion. Okay, the starting point of projectile motion. So at this point, what happened is the object will undergo horizontal projectile motion. Okay, it will drop. So it drops following this trajectory path. Okay, it follows this trajectory path and then it drops until here. So the things that you are measuring is this R. So this R is your range. You are measuring the range. So you put a carbon paper here. So when it drops, it hits the carbon paper, it leaves a mark on the floor. So you measure from this pendulum bob because this pendulum bob indicates the starting point of your projectile motion. So from this pendulum bob until the marks on the carbon paper. So the things that you're measuring is the R. So this H given is the height, is the vertical distance SY. The range is your SX. So if you go through...
We're supposed to conduct this experiment. I mean, this is a new experiment, is it?
No, you don't have to conduct it. What you're going to do, you just watch the video in the Feeboard. Okay, so for the experiment, for the non-home-based experiment, you watch the video in Feeboard.
Sorry, come again?
Your Feeboard.
Okay. All right. Okay, so you get the values from there, is it?
You got the video from there, you got the value from there.
Okay.
Okay, so everything is on your feedboard already. You go through the video and then you take the data from there. So how to conduct the experiment? Basically in the lab, you will have a setup that is exactly like this. Okay, you will have a retort stand, you will have a railing, and then you will steel ball. Your steel ball, you will start from here. Okay, you measure the height and then you drop the steel ball. And what you're recording is the R, the range. So in this experiment, okay, let's go through the procedure. So you set up the apparatus as shown in the figure just now, and then release the steel ball on the railing from 8 different heights. And then you record the values of R. See, you record the values of R. So you are recording the value of range. And then after that, you tabulate your data and then you plot the graph of H against R squared. So which means your table, okay, will have a H, and then you will have a R, and then you have a R squared. Okay, you have H, you have R, you have R squared. So you just measure the height, but I think the table is given already. You just get it from your feedboard in a Telegram. So measures the height of the H. So by referring, so you need the height of the H because you need the SY in your calculations. So by referring to the graph of H against T2 from experiment A, obtain the values of T2 for H using extrapolation. This one, if I'm not mistaken, the value is also given. Okay, so you just take the value from your feedboard and then you do the calculation. So calculate the values of G from H against R squared graph. Now, the question asks you to sketch a graph of H against R squared. So what are you going to do? You go back to the theory, you try to identify which equations come with H and R squared. So obviously it's equations 2.5. So what are you going to do in your calculations? Again, compare it with y equals to mx plus c. So obviously now, because you are doing a H versus R square graph, so H is your y, and then R is your x. So the remaining term is this one, is this part. This is your m. You don't have c again, okay? By comparison, no c. So this m gradient equals to 7 over 10 gt square, okay? M equals to 7 over 10 gt square. So t square should be given. Okay, t square is given. So you try to get the t square, the values of t square, and then you sub it into the equation. So from here, you then calculate g. So this is another experiment that wants you to calculate the g, okay, the accelerations due to gravity. So last step, let's see, what is the last step? So determines the values of delta g. Now delta g is not in your SEM 1 syllabus. In SEM 2, you will look at delta for G. Okay, you will have delta M, you will have delta G. But in SEM 1, because we cannot do it face-to-face, therefore they say skip it for SEM 1. But in an actual experiment, every graph, it should come with uncertainty. Uncertainty of gradient, uncertainty of gravity. Okay, but just because we are doing online class, we cannot let you use the software, so we cannot calculate delta M now. Okay, bukan kata dia tak wujud tau. Dia wujud. Cuma disebabkan PDPR, kami tak boleh bagi kamu kira delta M. That's why untuk SEM 1, kita skip delta M dengan delta G. But in actual experiment, you should actually have a delta M plus minus delta M, G plus minus delta G. There should be a calculation for these two variable. Cuma because PDPR kita tak buat. Tapi dia bukan tak ada. SEM 2, we will go through this. Okay, because I think face-to-face class already in a SEM 2. So SEM 2, I will guide you guys on how to calculate delta M and also delta G. But for SEM 1, leave it for now. Okay, so saya nampak ada pelajar SES masih buat M plus minus delta M, tapi delta M dia letak kosong. Actually, it's wrong. It shouldn't be 0. It must have a value. Okay, tapi but because of the PDPR, kita anggap dia tak ada, Alright, just assume. So compare the value obtained from the experiment with a standard value. So again, you want to compare the G that you obtained from the calculation with a standard value, which is 9.81 ms negative 2. So again, if it's less than 20%, then the value is accepted. Alright. So the experiment actually is very simple, okay? Just because you haven't seen the video, so maybe you don't have the idea on how it works. But the video can be found in a Telegram, okay, in your Feedboat. So kamu tengok video dia and then tengok pengiraan dia, okay? They shows you how to calculate. And if I'm not mistaken, you should have the value already. Okay, let me see. Go experiment 2 demo. Okay, yes, okay. Let me show you. Where is it? Okay, so if you look at this Feedboat, okay, this is your Feedboat SDS that I asked you guys to join at the beginning of the this SEM. So you go to the Feedboat, go to practical. Okay, practical, you got the experiment 1 until experiment 6, you got home-based experiment guide and also your ebook. So the experiments that you have to do it at home, we call it home-based experiment. The experiments that you're not doing it at home, okay, you're doing it in a video, okay, you do it through watching video, you copy the manual from ebook. So experiment 2, okay, you go to experiment 2. So writing report projectile motions, writing report for free fall, okay, tak payah tengok. So this is just video. So you go to demo projectile motion. It is video and the data projectile motion. Okay, so you have a demo and a data. Data, you use it for report writing. So you go to data, you open it. Okay. So you will get a complete value. Wait, let me show you.
Madam, just to confirm,
Yeah.
here we are supposed to draw the table, then we plot the graph, then we actually do the calculation. That is the 3 important things that should be emphasized in report 2B, right?
Yeah, but report 2B, because they give you the data already. Wait, let me show you. So this is the data.
So you don't have to write the procedure like the full report like you did.
No.
Okay, all right.
Okay, so you do experiments. You calculate it from here, and they miss out the T2. They miss out the T2. Then T2, you try to get it from your first experiment. Okay, you try to get it from your first experiment. See what is the value. So assuming your H, the height is 83 cm. So you extrapolate your graph. So experiment 1, you have a graph of wait, let me see what is the graph for experiment 1. Okay, so they miss out one thing. So you need to do it by yourself then. Experiment 1, experiment 2A, you got a H against T square graph. Okay, you got H against T square graph. So from experiment 1, you try to see when your H is equals to 83 cm. Okay, when your H is equals to 83 cm, what is the values of T2? Okay, so you get the T2 from your own experiment, from your own graph. Okay, so Okay, so you try to see what is the T2 when H equals to 83 cm. Just get it from your own graph. Okay, dapat daripada graph yang kamu hantar di Google Classroom. So when H equals to 83, you get the values of T square. So this T square, you substitute into the equation. Boleh faham tak?
This T square is obtained from the graph that we're going to draw, the earlier graph.
The graph from a 2A.
Okay. Right.
Okay, the 83 cm, you try to find the T2 from your experiment 2A. So from there, you then calculate this one. Okay, so delta M, you ignore it. Okay, you ignore delta M. You just use this table. Okay, you use this table and together with the T square from your experiment 2A. All right, T square from experiment 2A. The rest, you just ignore it. So what I want to see, you copy and complete this table. This table actually is incomplete yet because there is no R square. So you copy and complete this table. That is the first thing that you need to do. Second things that you need to do, you get T square. You get T square from your experiment 2A. Okay, you get T square from experiment 2A. and then followed by centroid, gradient, and calculations of G. Done. Okay, and the percentage of error. 4 step as usual. So you do until you obtain the percentage of error, then end story. All right. So for experiment 2B, what I want to see is whether you have already mastered the skill in sketching the graph, in doing the graph, and also the calculation. Okay. I don't want to see discussions anymore. I don't want to see procedure anymore. All right. But that's for experiment 2B. So can you understand?
Oh, just one more last question. This T square, right? When you
Mm-hmm.
obtain from the graph from report 2A, so you
Yes.
actually have to look to 15 cm, then we find the T square. Then 20 cm, then we find the T square.
No, you just want H equals to 83 cm, right?
Oh, so just only that only you have to obtain T
Yeah lah,
square, is
because
it?
you only want to calculate 1G, right?
Then for the table we don't have to include the T square, is it?
No, this table, why do you want to include T squared? This table, what is the things that you're measuring? Your manipulated variable is the H. Your responding variable is the R. Then why do you want the T squared? T squared, we want it just for the equations that I showed you just now.
Okay. All right, clear. All right, sorry, my bad.
So basically that is the things that you have to do. Okay, so it's a very simple. So you go to let's go back to a table. Let's go back to our Telegram.
Madam,
Yes.
for the table, we have to put the R average too, right?
Yeah, that's why I say you need to complete the table.
All right.
The table given is just a raw data, the data that you recorded directly from the experiment. But all of the calculations, they haven't give you yet. You yourself have to complete it. Okay, so let's go back to the Telegram. So now you have this data already. So you go to the demo projectile motion. So it is a YouTube link. So when you click it, it will shows you how to conduct the experiment. Okay, it will shows you how to conduct the experiment. So I think that's it. And then go back again. Experiment 3. So experiment 3, the data is also here. Okay, the data is also here. So today we're going to do experiment 3. Yeah. My laptop hang again. Annoying. Okay. Let me see. Okay, so today we're going to do experiment 3, which is energy. So energy, the data is given as well. Okay, so experiment 3 is not a simple harmonic motions. I think previously they give a wrong notes. Okay, they give the wrong handout in the Telegram groups. So experiment 3 should be experiment energy. Okay, experiment energy. So that is not a home-based experiment. Yeah, experiment 3 is also a video experiment. So what are you going to do? You just watch the video. Okay, you just watch a video demonstrations. So another video for you to watch. Okay, you got a video. So you watch the experiment for 3B, and then you take the data here, and you complete the whole experiment. So experiment 3, you need to complete the whole experiment. Okay, you need to complete the whole experiment starting from the title until the conclusion, because now it's a different experiment. Only 2B, I want to see the graph. So experiment 3 actually is next week. Okay, the works for next week. But then we just go through it now. Okay, so biar saya tengok. I don't have the pre-lab. Okay, let me change something because they give me the wrong handout. Experiment. So remember, experiment 3 is also a video experiment. It is not a home-based experiment. So basically, you don't have to do an experiment in your house today, okay, this week. So stop sharing. Let us go back to... Yeah, my computer is hang. Computer tua sentiasa hang. Okay. Yeah. Okay, so we take a 2 minutes break. Okay, kita rehat 2 minit sekejap while I try to find something. Okay, so you guys can get the breaks and then you prepare your pre-lab. Okay, so let us start. All right, so today we are done with how to use Google Classroom. And then we've done with a free body diagram in chapter 4. So we have seen 5 sample lab report. Now we are going to finish pre-lab. Okay, so once finished pre-lab, actually you can start to prepare for your experiment 3. Okay, but experiment 3, I will give you 1 week to complete it. I won't ask you to submit tomorrow. The things that you have to submit tomorrow before 5 p.m. is the calculations for projectile motion. Okay, I just want to see whether you have already mastered the skills in a graph sketching. That's it. So experiment 3, now let us go through the pre-lab. Okay, go through pre-lab. Okay, so a course learning outcome, solve problems related to physics of motions, force and energy, wave and thermodynamics. That is for SEM 1. So learning outcome. At the end of this lesson, students will be able to explain the experiments to determine the accelerations due to gravity G from the experiment. So again, it is an experiment for you to determine the accelerations of gravity, okay, due to gravity G. So read over the lab manual and then answer the following questions. First of all, you state the law of conservation of energy. So remember what have we learned in our lecture about conservation. Conservation, what is the things that you need to mention? You need to mention in a closed system, okay, or for a closed system. So for the closed system, so mean it is an ideal situation, ideal system, okay. The total energy, total energy. So this is a definition. It's already in your notes. The total energy is constant. Okay, or you can say the total energy at the initial is equal to the total energy at the final. Then state the gravitational potential energy and also kinetic energy. So you have to state the definition. Remember to mention one is because of the position and one is because of the motion. Okay, so you state the definition. It's in your lecture notes as well. And now what is the symbols and the SI unit for gravitational potentials energy? Symbol for gravitational energy is a U, G, and then for kinetic energy is K. Okay, so unit is J. So based on the situations below, answer the following questions. Now you're given situations A and situations B. Using conservations of energy determines the velocity, okay, before it reaches the ground. So what are you going to do in this case, in this example? So because we know that energy is always conserved, so summations E initial is equal to summations E final, right? That is what we do know. So what are we going to do? So you just substitute the equations, okay? You just sub the equations into the sub the value into the equations. So what you have here, okay, now these two of them, the two situations, now you have the same ball. So it means that M is a constant, okay? M is a fixed for both U and K. So initially, this is your U, okay? So U, and then the final position is just K, all right? Final position is just K. So for the second object, you have a U plus K, and then this is K. So you just simplify the equations. Remember, U equals to mgh, K equals to 1 over 2 mv squared. All right, so remember the equations, and then you just plug it in, and then you solve it. So basically, this is just like a tutorial question, okay, by applying conservations of energy. So you calculate it for situations A, and then you do the calculations for situations B. Okay. So from the answer calculator, what can we deduce about the relations between the release height and the velocity of the ball before hitting the ground? So the velocity, okay, the V should be directly proportional to height. Okay, V is directly proportional to H. So this is what you should observe. So later you can try it out, and then you try to look at the value, you try to look at the height, you try to look at the V. Okay, so for a 10-meter height, okay, this is 10-meter height, and then this is 5-meter height. So you observe what is the value for V. Okay, what is the values of V? So a 10-meter height, it should have a larger V. 5-meter height, it should have a smaller V. So in that case, we can conclude that they are directly proportional to H. Okay. So what is the energy owned by the ball bearing when it is attached to a adapter, free fall adapter? So this pre-lab. Okay. So what is a free fall adapter? Now in the experiment 5, you have this is how it looks like. This is the setup of the experiment. Oh, why do I want to draw it when I have the lab manual with me? Okay. Let's go through the experiment. So we are not doing experiment 3A, yeah? We are doing experiment 3B. Make sure you don't copy the wrong lab manual again. So experiment 3B, energy. So energy, okay, the learning outcome, you yourself change it into objective, and then theory, you just copy it as usual, right? You just copy it as usual. So I'm going to skip it because we have learned it in the lecture. So the apparatus, you have a steel ball, a meter ruler, a free fall adapter. Now, free fall adapter is a new term to you. Okay, and also we have a velocity detector, which is the 2 photo gates, and then a timer and a retort stand. So this is how it looks like. So this is a free fall adapter. Okay, free fall adapter actually is a piece of electromagnet. When you switch on the power, this is a free fall adapter, it will act as a magnet, and then it will attract the ball. So the ball will stick to free fall adapter when you switch it on, when you switch on the power supply. Right. So what happened is, okay, after you switch it on, the ball attached to it, and then you just release the ball. You press the button to close it, to switch it off, and then it will release the ball. So when you release the ball will go through this PGA and PGB. PG is a photo gate. Photo gate is like a motion detector. Okay, so there's a laser, the infrared inside the photo gate. So when the ball passes through PGA, the sensor detects a ball and it will start the timer. Okay, timer will start at PGA. And then as it keeps going down, the ball passes the second sensor at the PGB. And at that moment, the timer will stop. Okay, so the times that you record actually is just in between the distance between PGA and PGB. So as you can see here, it's just the S, a very small distance, okay, between these two photo gates. All right, so you measure the times taken for it to go through, for it to pass through PGA and PGB. So you record the time when it passes through PGA, you stop the timer when it passes through the PGB. Actually, you don't have to stop it manually, it's automatic. Okay, it uses a sensor. So free fall adapter is this piece of magnet, okay, the piece of magnet here. So it attracts the ball attached to it, and then you release the ball passes through PGA, timer start, and then it goes through PGB, timer stop, then you record the time. Okay, you record the time. Basically, that's it. Okay, basically, that's it. So you manipulate the H. Okay, you manipulate H, and then the responding variable is a timer. The things that you record is a timer. All right, so that is the experiment. So construct a velocity detector by sandwiching the photo gate. So that is your light gate. So you sandwich it. Actually, in the experiment, the lab assistant already taped the two photo gates together. So you don't have to do this, the step 1. So what you have to do is just to measure the distance between photo gate. And then set up the apparatus as shown in figure 3.1. Switch on the timer, reset it to 0. So set the falling distance at 15 cm. So you manipulate it. It starts from 15 cm, and then you slowly increase it. And release the steel ball and then record times t. Repeat the process to obtain average time. And then you repeat the step for H20, 25, 30, 35, 40, 45. So this is your manipulated variable. Okay, this is your manipulated variable. And then tabulate your data. For each H, you need to calculate V. So now your table, you need to include an additional column for V. Okay, you need to include an additional column for V by calculating V equals to S over T. So you have a record H, and then you have a T1, T2, T average. Okay, and then you put a column for V, and then you calculate V squared. So basically, this is what you should have in your table. Okay, this is what you should have in a table. So plot a graph of v squared against h, and then use the graph to determine the values of accelerations due to gravity and compare the values of g with the standard value. Now, if you look at this step number 6, v squared against h. So what are you going to do? As usual, you go back to theory. Okay, you need an equation that consists of v squared and h. So equations 3.1, no v squared, so it's out. Equations 3.2, again, no v squared, it's out. And then equations 3.3, yes. Okay, you have v squared and h. So this is the equations that we're going to use. So again, you compare these equations with y equals to mx plus c. After that, the step is exactly the same as what we have learned in experiment 2a. Okay, by comparisons, you try to identify which part of the equations represent gradient. Then from there, you determine the values of g. Okay, so again, after you determine the values for g, step number 8, you can skip it. You don't even have to write it. And then, does it verify the laws of conservation of energy? So now it asks you whether it verifies the law of conservation of energy. You use the g to calculate your E and also your U. Okay, your K and also your K and also your U. See whether it verified or not. Right, so you just put okay, you just explain it a little bit. So done. Okay, experiment 3 actually is just a very simple experiment. You will have a better picture, better idea after you watch the video. Okay, it's a very, very simple experiment. Usually this experiment, students finish within half an hour. Okay, so let's go back to a pre-lab. Okay, so what is the energy owned by the ball bearing when it's attached to the free fall adapter? So when it is at the highest poles, when it is at the highest positions. So when you attach the ball at the free fall adapter, when it is at this position, what is the energy that it has? So it is not moving, and then it is located at a height above a ground, okay, at a certain height. So means that this one, it has only a gravitational potential energy. Okay, so it has only UG. So what is the usage of a photo gate? Okay, so it is used as velocity detector. Okay, velocity detector. Or you can also say you use it to record the time. Okay, record the times. Record the times taken to travel from BGA to BGB. Okay, so this is the usage directly in the experiment. Okay, this is the usage after you calculate the velocity. So it can be used as a velocity detector. State the change in a mechanical energy in this experiment. So what happens? Initially, you have only UG, gravitational potential energy. After you drop it, after you release the ball, potential energy slowly change to kinetic energy. Okay, it slowly changed to kinetic energy. So UG changed to K. State the related variables that need to be recorded in this experiment. So like I told you just now, the manipulated variable is the H, responding variable is a T, right? So remember, responding variable is the variables that you record directly from the experiment, not the variables that you calculate. Okay, a lot of students got it wrong because they put V here. They told me, okay, miss, now the question asked me to plot a graph of V squared against H. Isn't that my responding variable should be V squared? No. V squared is some things that you calculate. It is not some things that you record directly from the experiment. Responding variables, usually it refers to the things that you record straight away from the experiment. In this case, we record time. So time is our responding variable, not velocity. Okay, so make sure you are clear what does it mean by responding variable. Responding variable is the variables that you record directly from the experiment. It is some things that you're not controlling. Okay, so how the final velocity of the ball bearing is determined. So let Manuel give you the equations already, which is V equals to S over T. Okay. So data analysis and equations for a straight line graph is a y equals to mx plus c, whereas while y is the quantity on the vertical axis, x is the quantity on the horizontal axis as shown in below. So now it asks you the velocity of ball bearing is related to the height released by the ball. Okay, you're given this equation. This is the equations that you want to use in your calculation. So based on the equations 1, determines a variable for x axis. So which part of the equations represent your x axis? Which part of the equations represent your y axis? Okay, you think of it. And then which part of the equations represent m? So from the graph, how can we determine the values of g? Again, this is something that I told you already. What is the equations for g? Okay, so basically, if you understand this component, means that you should be able to do the calculations already. Right? So list the 3 precautions and state 2 types of errors and give an example for each error. So you see, even in your pre-lab, it asks you to give example. Okay, it asks you to give example. And remember, I don't want 0 error. Okay, don't give me 0 error. Don't give me random error. Okay, don't give me parallax error. Okay, especially 0 error and parallax error. I don't want to see in your lab report. Okay, still got 1 or 2 of you give me this error in your experiment 2A. That's why I put a big cross there. Okay, I don't want to mark it. So no 0 error, no parallax error. Random error depends on how you explain it. If you can explain it well, then you can use it. Okay, but 0 error and parallax error, definitely I don't want to see it in your experiment 3. So I'll give an example. Okay, explain it. And in your official practical test, error and precaution, they must be related to each other. If you give a precaution that is not related to the error, then it will be considered as wrong. All right, it will be considered as wrong. Okay, so based on the situations below, identify either it is a random error or it is a systematic error. Okay, or it is a systematic error. So wind keeps blowing in the surrounding using the experiment. Okay, this show affects the velocity measured in the experiment. The best way to solve it is by conducting the experiment in a closed area or a vacuum space. So wind blowing, it won't give you the same error every time. Okay, in that case, we call it random error. Okay, the error that won't give you the same result every time, we call it random error. The error that gives you a same error, same reading every time, same mistake every time, we call it systematic error. So that is the main difference between these 2 types of error. So some of the numbers on the timer display was broken and missing. Okay, thus reading can be taken only to the nearest decimal point. So the missing value or the broken value is always the same value. Means every time you repeat the experiments, you will have the same mistake. In this case, we call it systematic error. Okay, so it doesn't matter how many times you repeat the experiment, you're going to get the same error. Same and constantly happen. So in this case, we call it systematic error. So instead of using hand to release the ball, it is suggested that ball can be released using the automatic control trigger. If you use hand, sometimes you release it faster, sometimes you release it slower. So the error is uncertain. Sometimes you might release it on time. So in this case, again, we call it random error. Okay, because the mistake is not constantly happen. Sometimes happen, sometimes not happen. Sometimes it's faster, sometimes it's slower. Okay, it is uncertain, it is not constant. Okay, next one. Sometimes the times measure is hardly detected by photogate. This is due to the positions of the photogate where the ball bearing fails to hit the motions of the sensor. Therefore, it must be realigned properly. So if it's not realigned properly, then maybe every time you got the same wrong value. Okay, maybe it's slightly faster every time, or maybe it is slightly slower every time. So in this case, we call it systematic error. Okay, systematic error. So every time same error, and it constantly happen, not just 1 or 2, okay, 1 or twice. Okay, if you repeat the experiment for 10 times, then you're going to get the same error for 10 times. Okay, and the margins, the values that is the same. Okay, the error is the same. So that one we call it systematic error. All right. So all this error, you can tweak it a little bit, you can change it a little bit, and make it into an error in your discussion. Okay, tak kisah. But make sure you explain it. It depends on how you explain it. Okay. Broken apparatus, I don't want it as error actually. Okay, jangan bagi saya broken apparatus dan sebagainya. Because in your experiment 2A, got students tell me the ball pen is broken. And then precaution, replace a new ball pen. Well, if it is already broken, then how did you conduct the experiment? So jangan sebut broken apparatus in your discussion. If it is already broken, how did you conduct the experiment? Jangan beritahu saya replace new apparatus. Okay, because in that case, I can replace new apparatus in every experiment. All right. So that marks the end of pre-lab 3. Any questions? So pre-lab 3 is not very hard. Okay, pre-lab 3 is very simple because the questions they ask is based on your lab manual and also your lecture. So so far, any questions? Oh, tak ada questions? No questions? So if no questions, I think that's all for today. Okay, you all may leave the class now. So thank you for attending the class.
Thank you,